Yeah. So the cool thing about inflatables is for launch, you can pack them quite small, right? So we are not the first ones to come up with that idea. The idea actually is like a mixture of some early Russian developments and then some NASA push that actually made it technically feasible and brought it up to TRL-9. So what NASA pretty much developed these inflatable heat shields for is Mars landing. Right? Because as I think most listeners will know, the Mars rovers that are on the Mars surface right now, like 1 ton class roughly, they are at the upper limit of what's possible to put on Mars right now with current heat shield technology, right? Because you need a certain size of heat shield to bring 1 ton down to Mars. And that heat shield just barely fits into today's rockets, right? So if you want to bring something heavier than 1 ton down to the surface of Mars, the heat shield would have to be even larger than that. And then it doesn't fit into the rocket anymore. So what's the solution? Well, you fold the heat shield, right? That was the whole thinking on the side of NASA. And what they did is they put 1.5 metric tons into low Earth orbit and then deorbited it and successfully brought that through the atmosphere with an inflatable heat shield, which was super nice for us because at that point, our company was just 1 year old and NASA had just taken a technology risk out for us. So we were like, thank you, NASA. When it comes to the actual details, there are some major differences between what NASA does and what we do. NASA, for example, carries all of the gas needed for inflation up to space with the vehicle. So they use exclusively nitrogen from gas bottles to inflate rubber tires. These rubber tires are then reinforced with Kevlar to form like a proper structure. And then because rubber and Kevlar, they cannot go to very high temperatures of reentry. They have several layers of insulation. So we said, looks pretty good already. Maybe we can still improve that by reducing the amount of layers, right? And also by reducing the amount of gas that we have to carry with us. So instead of having like, rubber tires and Kevlars to carry the load, we actually have ceramic fabric that actually carries the load, which means our whole structure can get to those hot reentry temperatures. And number two is we use what we call an air breathing system. So as soon as we are inside the atmosphere, we use little electrically powered turbines to suck air from the atmosphere inside of the heat shield to keep it inflated.